Determine the sum of the series whose nth term is given to us. Okay, let us begin. So here we are going to suppose that let Tn represent the nth term of the series such that Tn is represented by n squared plus 2 raised to the power of n. Okay, now what we'll do, we'll suppose that let Sn represent the sum up to n terms where the nth term is given by Tn. Then in that case we can represent the sum n as the summation of the nth term of the sequence. But what we'll do, nth term of the series, but what we'll do, we're going to replace the index n with k, and k is going to go from 1 to n. That means we need to find out the summation of k squared plus 2 raised to the power of k, with k running from 1 to n. Okay, so we will simplify the summations. We have summation of k squared with k going from 1 to n. That will be added to summation of 2 raised to the power of k with k going from 1 to n. Okay, now what is summation of k squared? Summation of k squared, that simply equals to 1 squared plus 2 squared all the way up to n squared, and this is simply the sum of the squares of the first n natural numbers. We have a standard formula for this, and it's given by n multiplied to n plus 1 multiplied to 2n plus 1 whole divided by 6. Right, so here we have n times n plus 1 times 2n plus 1 whole divided by 6 replaced in place of summation of k square. Then coming to the next term, so here we have summation of 2 raised to the power of k. Now what is summation of 2 raised to the power of k? So this is simply, now we have k going from 1 to n. So if for the first term we replace k value with 1, we get 2 raised to the power of 1. That will get added to, because we are performing a summation here. The second term will be for k equals to 2, we get 2 squared. Then we get 2 cubed. And this goes all the way up to the last term, 2 raised to the power of n. Now clearly this is a geometric series with n number of terms. The first term being a, the common ratio r, that's equals to 2. Now since the r value that's equals to 2, clearly its magnitude is greater than 1. So here the formula for finding the sum up to n terms of a general geometric series is given by a multiplied to r raised to the power of n minus 1 divided by r minus 1. So that means summation of 2 raised to the power of k. So that's going to give us, so what's the first term? That's simply 2. We have 2 multiplied to 2, that's the common ratio raised to the power of total number of terms. So that's simply going to be n minus 1 divided by 2 minus 1. So further simplification gives us n times n plus 1 multiplied to 2n plus 1 whole divided by 6 added to 2 times 2 raised to the power of n minus 1. So this is going to be the sum to n terms.